Right. Good morning, everyone, and welcome to adaptTo, the first real session, I would say, for this morning. And actually, we are starting with a deep technical talk this morning, so it might be a little bit tough at some places, but I think this sets the baseline for the whole conference. Just to give you a brief idea of who we are. That's me, nice picture over there. I obviously work for Adobe as a principal scientist on the AM product. I'm part of the Apache Software Foundation, and I was involved in Sling and Felix a little bit over these times. I'm also doing some OSGi stuff. More interestingly, here's my colleague Karl, and he works for Adobe as well. Also a member of the Apache Software Foundation, involved in Sling, and especially involved in Felix and all the OSGi stuff. So if you have a very deep OSGi question, he's the man to talk to, because he also wrote a book, or co-authored a book about OSGi. But more interestingly, what are we going to cover this morning? We will look a little bit into Java9 and how that works together with OSGi and the work we did in Apache Felix and Apache Sling to better work with Java9 and also, of course, Java10, 11, and hopefully the upcoming versions. And then the second part will be about what's new in the OSGi R7 release, which was released earlier this year, so you can make advantage of those new things and start using it. So, and now I hand over to Karl and can fall asleep for some time.
Definitely. Yeah, welcome to this sub-part of the talk, and I guess Java9 is a little too broad a topic in reality. It's more JPMS, so the Java platform module system that we're going to talk about for the most part here. But it started being available with Java9, and obviously having a new module system alongside OSGi is a bit of a challenge, especially in this case, since the one is built in by default and the other one is optional. So during the last couple of years, there have been all sorts of attempts to make that work together well, or at least better, or maybe at all. I did some work in initially getting Sling to run on it, and now to work with it even better with Java 11, and we adjusted Felix a bit. So, but I want to quickly go over what we're talking about. So, JPMS on the one hand side is meant as a way to modularize the JDK. So what they did is they introduced the module system, and they split up the JDK into modules. I think it's 24. Some make more sense than the others. So logging makes some sense as a module. The other one are more like a kitchen sink kind of thing, desktop and things like that. And they introduced the concept of having virtual modules, which are just aggregating others together, so that you can get kind of profiles kind of thing going. So you have a Java SE aggregator module, and you have one for Java SE, which contains 6 modules, which for the most part contain the code that has been grandfathered into the Java SE world from Java EE, and they immediately marked them for not only deprecated, but deprecated for removal. So we have 6 modules which are going away in Java 11. So they will not be around at all. To emphasize that point, they from the get-go made it so that they are not available by default on Java 9 even. You need to add them with a -- add module switch on the command line. Again, you can use the java.se.ee aggregator to get all of them in one go. But if you don't do that, they're not lauded. No, it was to re-emphasize that they're going to be gone in Java 11, which now really is the case. You get replacements for most of them. The odd one out is Java Core. If you're still using Core, I have very bad news for you. And then they also deprecated some internal stuff, especially unsafe, which they at least threaten to take away in the future. It's not clear when or how, but so obviously now they can control the borders of their system a little bit better. They want to do it. The other side is that they also made JPMS available for things that run on top of the JVM. So you can create your own modules in this world. For that, there's now a module path which sits alongside the class path. In fact, the class path is treated as yet another module. It's called the unnamed module. So the way this works is the unnamed module can see everything on the module path by default, but not the other way around. So you cannot have a module that depends on anything on the class path, but you can have something in the class path that depends on something in a module. Modules themselves, the model is not that super sophisticated in that sense. You just add some metadata in a file called moduleinfo.java. Where you can say what packages you export and what other modules you require. So from an OSGi perspective, it's mostly a require bundle concept, and you can do something with services, uses the normal service loader mechanism. The difference is it doesn't go through the class path to pick up services, but you declare that in the metadata, and then it wires you up based on that. They changed the access level, so that's a bummer a bit. So far, if you had a type, you called set accessible on it, and then you could do reflection on it. That's not the case anymore. It only works for packages or classes that are exported to you. Otherwise, you get exceptions. Even so, you set accessible. And there's no split packages, and that's because by default, there's only one class loader for all modules. So they didn't do what OSGi did, having side-by-side class loaders. They, put it all in one class loader. So there's no split packages between modules. It's an error to put two modules with the same package on the module path. You can have recursive use cases, so you can create your own layer. I call it module layer, where you put in modules at runtime. But right now it's not used that much, so we have to see how that works. And part of, or maybe the interesting aspect of that, is that they now allow you to, using a tool called JLink, create custom runtimes, which only contain the modules you need. So you can create significantly smaller subsets of a JDK if you don't have that many dependencies, right? Again, Core is gone already, but if you, for example, don't need desktop or Swing, you don't have to put the module in, and then you get a much smaller runtime using JLink. So that's interesting. The other thing I want to quickly mention, because we need it a little later, is they introduced something called a multi-release jar. It's meant as a way to organize backwards compatibility. So it's very simple. If you put a multi-release equals true, or multi-release true in a manifest of a jar file, it's a multi-release jar, which means that if you put classes or resources under meta-inf versions n, where n stands for the major version of Java, used, that's going to shadow whatever else is on top of the chain. So you don't have to special case the JDK version anymore. You can shadow it inside one jar. If you have some optimized code on Java 10, you can put the class under meta-inf versions 10, and then it will shadow it automatically if you're on Java 10 or higher, basically. I'll get to why that's important in a second. So given that we have JPMS now, and what does that mean for OSGi? So the one hand was getting OSGi to work on it. Well, that we sort of managed, but there were some adjustments that we thought were necessary for immediately. I mean, hopefully in the future we get even more stuff in the spec, but for now we settled with two things. So the one is, obviously it presents a challenge that you now have a platform which can change, right? If I JLink together a smaller profile, well, there's less exports available, right? Or there's more exports available, or Java SEE is not on, or it is on. So it's much more dynamic what you can expect from the JDK than in previous iterations. So, and that also includes Java.star packages. That's new, right? I mean, previously you assumed, okay, Java 8 comes with Java util prefs, right? It doesn't anymore, not necessarily, right? If I J-link it without Java util prefs, then there's no Java.util. So we allow Java.imports now. They're sort of optional because we effectively still boot delegate them. So if you don't have them, you still get the classes if they're there, but you now can express that you have a dependency on Java util prefs. So in other words, you shouldn't, or you cannot use the OSGi EE capability anymore exclusively to sort of express your dependency on a certain Java version. That is more now intended to be used as expressing what bytecode level you assume, right? So if your bytecode needs Java 9, you should, require OSGi EE in version 9 to work. But for the rest, you should start adding Java imports alongside it. And we also added support for multi-release jars. I mean, that makes some sense. It's your bundle can now be a multi-release jar as well. Just set them multi-release true, and it's treated like that. And the same happens for bundle class path entries if there's jars on them. So that's not that newsworthy, but the main point here is that because of that, we felt that this is not enough, because for us it's a challenge, because if I shadow some class in Java 9, it might start to introduce different import dependencies and or requirements on capabilities. So we introduced this notion of a supplemental manifest. So now if you install a bundle that is a multi-release true, we will look into the matching meta-inf versions directory for an OSGi inf manifest. If it's there, we take the import package and require capability headers, if you have any in them, and substitute them in. So this way you can adapt your jar to different Java versions, basically if it's a multi-release jar in one bundle. So this is actually the way to that, because in R6 it wasn't allowed to import Java star packages. So if you have a bundle that is supposed to work on R7 and R6, like it's going to be the case for a while, I guess, because out there, AM, for example, and stuff like that, is all releases are still on R6 for now. You couldn't install it. So here the trick now is to say, well, if you're in that situation, you probably want to make it a multi-release jar and push your Java imports down into the supplemental manifest, so that they get ignored by R6 frameworks because they don't know about multi-release jars. And for R7 frameworks, it just works then, with the exception that they're not available on before Java 9, but that doesn't matter because the whole idea was we need them for Java 9 and above. So that was it from the OSGi side for now. Again, we hope we get more support in the future, but we didn't have that much time until R7 came out, so already some of that was shoehorned in the last minute. I did some more stuff in Felix. So on the one hand side, Felix now by default will calculate the system bundle exports dynamically. So you get from the system bundle all packages that are really there. There's an option to have that done with users constraints between them as well. It's an option because it takes about 1 second to do that. So if you're a desktop app and want to start up fast, you don't necessarily need it. Plus, you can give Felix a list of modules you want to have visible if they're there, and then take advantage of the fact that Felix will check if they're there and only put the exports in if they're there. Okay, so you can overwrite those too if you want to. In other words, we're a little bit more flexible now in how you can deal with those modules. This is more just for completeness sake, if somebody wants to look it up later. So there's a property for, say, okay, calculate users, that calculates the users, and you can enable system package substitution. And if you do that, then and that's not spec, that's just Felix. We allow you to use the org OSGi framework system packages or org OSGi framework system packages extra properties to have some kind of substitution going on. So in the way that works is that Felix, for each module it finds on the module path that's accessible, will calculate the packages that are in there, calculate the users constraints, and then populate a property, right, which is going to be called felix.jpms.module name, right? So if there's a java.sql module on the module path, we provide a property with that prefix, and you can reference that with a $sign in the system packages or in the system packages extra. So this way you can create your own system packages if you want to, based on available modules, and can limit it. Right? If you don't specify those at all, we calculate them dynamically and you get everything. But you can limit it or augment it too if you want to. Again, more for reference sake here, so if you don't, it just re-emphasizes the three possibilities. You can overwrite one of those profiles by giving a different Java SQL in this case in the upper line. We do that in AAM actually because we need to increase the version of the JavaX transaction XA package. Then you can do system packages which just have only your modules you're interested in, which will then be substituted if they're there. If not, they evaluate to nothing. So they're not there. And, well, you can combine that mechanism with standard profiles for Java 8 and before that, which is actually what I'm using in Sling now. So starting with the latest snapshot of Sling 11, I started to use this stuff. So basically, well, we have users constraint calculation on by default, and we have property substitution on by default. That's what you get from the Launchpad base. But previously, the Launchpad base used to bring its own profiles for the different JDK versions, right? So they were not 100% what's really there. They were already messed up a little bit. So by default now, if you just use the Launchpad base without anything else, you get the real Felix profiles if it's below Java 9, or the dynamically calculated what's really there if it's Java 9 or higher. That's nice, I think, because if you just use the provisioning model and put in the Launchpad base without any specific properties, well, you get what's really there. And then if you want to give a specific profile, you can still do that. So we need that, for example, because, as I said, the Launchpad base used to have a very specific profile, so we have to get that back. And you can do that by using the system packages or system packages extra properties with property substitution on, either directly via the provisioning. So I changed Felix to pick that up from the properties if you give it. So you can put it into provisioning, which is what I do in the current snapshot. Or you can later on use the Sling properties file to overwrite those before you start up. So if you know that something has changed and you want to adapt, you can do that via the Sling properties. So I don't know if anybody paid attention, but I think in JAX 6.4 already it started that we had somewhat funny definitions in the Sling properties for package profiles. And this will continue, and there you can change what you have based on what I had in the slide before, either on complete just JPMS modules, which you say, I want this if it's there, or if you want to overwrite those, there's a couple of overrides we have in there, which you can set this way as well. So that makes the situation a lot better, and for now at least, I opted for an interesting variant here for the defaults, which is basically, since Java 11 for sure will not have the deprecated modules, and they're not on by default for everything below it, I sort of made it so that we now have a consistent set of packages along all JDKs. So I also for JDK 8, made it so that I removed the packages which are not available in Java 11 anymore. And then I added bundles back in, real bundles, which provide the missing functionality. So it can happen that if you're in Java 8, well, you have a bundle providing certain packages, and they would be as well available on the class path or from the JDK, but we're not going to expose them. So now we have a reasonable, consistent set of packages from the system bundle by default if you just use any Java version, and the rest comes from bundles. As again, Core is a big exception. I mean, there's no replacement for Core, good or bad. I'm not sure how much it's going to help, but I can quickly show at least a little bit of that, how that works. I hope. Exactly. So, okay, let me see if I get this done. So, let's start with, I mean, I'm going to, and there's, ignore the command line for a second here, but I mean, basically, so let's start with, so to show what we're talking about. I mean, if you're looking at the normal, and that's obviously, it's not the JRE, it's a JDK, right? But if you look at the normal JDK directory, it's like 500 megabytes big, right? There's some tools in there, but it's hard to pass out of another. We're talking about roughly 500 megabytes. Now I can use JLink to, let's, for starters, boil it down to some SEEE. So I here say add modules Java SEEE, and so that means it adds the virtual wrapper. So it gives us roughly what is in the normal Java doc for a JDK. Okay. So now I have a base SEEE directory in here, which is a boiled down platform of it. So if I now look at that, well, that's only 102 megabytes, right? I mean, that's partially because the tools are missing, but it's also stuff missing like Java FX, which is normally around, and some Derby stuff, and some other localization stuff. You can trim it more, you can compress it, so there's some more options to make it even smaller, but this is now giving us a baseline here. So, and as we know, Sling and most of our stuff works at least with Java SEEE. So I have a very minimal environment here, which is not actually really Sling. It's using the feature model to build it, but it's really just something to quickly show. It just has the web console, basically. And if you see here, so we started that on this new base thing. So that's only SEEE. Yeah? So you can see we have now exports for Java dot packages. They look a little ugly in the web console, but I mean, they're there. But we still get the reasonable big profile here, right? So you have Java Swing, you have the Core stuff. So it's a big platform, right? So if we now quickly try and say, well, okay, how does it look if I don't have the 6 deprecated modules on it? It's only missing those 6 deprecated modules. We immediately run into resolution errors. Because for the most part, I don't know if you can see, but for example, here we're missing this Java's annotation thing, which is one. But there would be more, right? So we cannot run without those deprecated modules at the moment with these bundles. So what I can do now is, let me clear that again. I can quickly go and create me a hand-picked list of modules, which are roughly what we need to run this thing. It's Java-based, Java logging, Java XML, VS annotations, and one or two others. And then I have a platform which hopefully allows me to start, but also it's only 52 megabytes, right? So we halved it again, right? So this is the minimum we need for this example, and that's already, you could get it further down if you would clean up some of the stuff that we in reality don't really need, like the annotation stuff. I mean, that pulls in a lot of stuff. So you could get it even further down. But it's nice that you don't have to have this big JDK on it. And then, so if I start that up, just because the web console is nice to look at, then you see now what the system already did is it just adapted to it. So we still get some Java exports, but the com.sun are gone, so and they're a lot less. It's harder to see here, and you can see that for the normal profile, well, that's a lot less. There's no swing, there's no Core, you know. So it's a lot less packages available, and that just automatically works, so to speak. So that's a big change. And I guess I'm running a little low on time here, so I don't want to drag it out for too much longer. But the main idea was here to show that well, we can now create a multi-release jar, which allows you to import Java packages, but they still get boot delegated. So let me quickly do that, just for the kicks of it. Okay. See, yeah, there you go. So here we have an example which only imports Java util-prefs. Right, so it's a Java package that gets imported, but it's overwritten by boot delegation. That's what it tells you here, right? So it's overwritten by boot delegation. And again, I could show you that you can use a multi-release jar to make that work with R6 frameworks, but I think that's for now, since I'm running out of time, not necessarily. We don't have to do that, but I have a GitHub repo which I put the link into the slide, so you can look at that. But that was the main exercise, that if you use a multi-release jar, then on R6 it will not have that import, but on R7 it will. So, and then to conclude this, I mean, if I show you here if I attempt to install that example now on my minimal platform, it should not resolve because we didn't put the Java util-prefs module on the class path. So, okay, I'm in the wrong. Go. Damn it. Let's see if it doesn't, and then we're done with the demo. Whoop. Okay. So I reinstall it now, but on something that runs on the minimal platform. And there we go, it's only installed, and that is because it's not finding Java util-prefs. So I could add that module on the module path, start again, then it would work. So that was it. And so coming back here, okay. Right. So just a few closing words, and then I hand it off to Carsten. So yeah, we have Java 11 around the corner. The deprecated modules will be gone. We made it so that we don't have to change Felix and COE anymore for new Java releases, so that should all work because we calculate the OSGi dynamically, the packages dynamically, and stuff like that. So there's not, like in the past, the requirement to re-release Felix and re-release everything else to just get a new major Java version support, at least for now. One nice thing about Java 12, maybe it made it into Java 11, I'm not sure, but since now the deprecated modules are gone, they're probably going to make it so that all modules that you have in your base platform get loaded by default, so you don't have to do any command line switches either anymore. But quick word on tooling. So unfortunately, for multi-release jars, we still have some work to do because Maven doesn't support it too well, and BND still need to catch up on it a little bit as well. It works a bit, but it has some issues still. There's an issue for it, so I hope it happens quickly. And then ultimately, the goal is to get BND to support this whole, both of it, so that you can just say, okay, calculate my Java star imports and turn it into this backwards compatible multi-release jar. It's hopefully happens soon, but it's not yet done. So you can do it like I did in my example by hand, but yeah, I mean, hopefully the future is brighter than that. So in summary, we're not by any stretch of the term done or super interoperable between JPMS and OSGi, especially not since the other way around doesn't really work. Maybe there's something in the future, I don't know, but for now at least we get it to work. I think with the runtime discovery of packages, it starts to become nice-ish, and with Java imports, at least you get a good foundation. The reflective access is still a little bit tricky. Right now we have this exception that at least what was public in the JDK previously still works out of the box. That's going to go away at one point of time, so the framework will probably need to re-release for that eventually. But yeah, I still got to look into that. On the bright side, I still think that hopefully in the future, with either the provisioning or the feature model, which is new, we might be able to do smarter stuff, which comes down to say, well, I want to run this, and then we could look over it and say, okay, this is the JDK platform that you minimally need for it. So we generate it out, and then you had a smaller runtime thing in one go. Well, that's my goal for next year, I guess. And then with that, I hand it over to Carsten again.
Okay, thanks. So while standing over there, I actually realized that I gave the image of a typical German handing a glass or a bottle of whatever in his hands, which you usually see. Anyway, just a lame joke to start my part. So I'm now talking about other things we did in the OSGi R7 release. Again, this was released earlier this year, and nearly all of that stuff is, in the meantime, available and can be used. We start with something which doesn't look that much interesting, but we added a lot of new annotations that you can use in your projects. And basically, these annotations allow you to define everything which you used to define in a manifest now in Java code by using annotations. That's if you want to add a requirement or a capability to your manifest, you can do this now with annotations. Other things like a bundle descriptions and all these things. In addition, when it comes to versioning and exporting of versions, in the R6 release, there was already the version annotation and these two other annotations there. But that just meant that this package has a version. It didn't really mean this package should also be exported to be used by others. So this gap is now filled with the new export annotation. So you should use the version and the export annotation to export a package. And then, like I said, you can now basically define any header of the manifest in Java code. For example, if you want to add this requirement that your code requires the HTTP implementation, you could just use this annotation, or you want to add the bundle category header to your bundle, then you use the other one. And all these things can be done using these annotations, which is kind of nice because everything is now code and not somewhere else and some additional files. But it gets even better, I think. For example, if you're using declarative services to develop your services and components in Java, you should actually, or your bundle should actually require the declarative services extender, which would mean you have to write this requirement into your header. Now you can do this in code, which is this lengthy statement over here. But the good thing is you don't even have to do that. As soon as you're using some DS annotation like component, this is done automatically for you. And this is where the interesting part comes in, because we use meta annotations to do that stuff. This might be a little bit tricky to explain, but basically we defined this require service component runtime annotation, which has the requirement annotation, right? And this requirement is what you want to have in your manifest later on. And then the component annotation, which is the annotation that you use to code your components and services, has this above require service component runtime annotation. And magically, by using tooling, B&D tooling, this adds then the requirement eventual to your manifest. So you don't have to care about these things. And we did this for quite a lot of different specifications, so not only DS, but others as well. I get to that in a second. We improved declarative services and added a lot of interesting stuff there. Basically, or the most interesting things, I think, are these two here, using activation fields and constructor injection. And I will give some example on the next slide. And again, we added some annotations, which I have to explain. So the first thing is the field activation stuff. So basically, you can now annotate fields with activate, and when your component gets activated, these fields will be set with this stuff. And that's usually things that previously you had to write a simple activate method for, like to get the bundle context, your configuration, and all these things. Now we can just annotate a field, and the field gets that object. So it simplifies your code. And the other thing is constructor injection, which people wanted for a long time, and now it's here, and you can use that. And basically, you can use anything that you that's a strange explanation. You can use anything in the constructor in the end. So you can have references to other services. You can use the bundle context configuration, whatever you want to initialize your component, you can put in the constructor. And this obviously allows you to use, for example, final fields for all these things, but it also gives you more stability about ordering of references, because everything which you put into your constructor will be set first, obviously, because the constructor is the first thing that gets called. So in all your other methods and code in your component, you can rely on that you have this thing already, which is quite handy. And the other thing is that we came up with this component property type annotation, and you can put that on annotations. Again, this is two-level thing. And this basically then allows you to use the final annotation, so to say, on your component. For example, we have this service description annotation here, and now you can just use that on your component, and it adds then a service description property to your component, again, simplifying things. We see some other usage of that in a second. And we did a lot of other interesting things. For example, the log service, which was not updated for the last 10 years, probably, or something like that. Never, yeah, probably that. Got now updated, and it provides the same capabilities as Left4j. The interface looks pretty similar. So if you want to use a log service for logging, this is now much nicer. I think more interesting are two other specifications, the converter, which basically allows you to convert one object to another one, and push streams, and then promises got updated for doing event-based reactive programming in Java. So very nice things. And especially the two here, converter and push streams, can be used without an OSGi framework. They are just libraries. Okay. To give you some examples about the converter, as I said, you don't need an OSGi framework, you don't need to use services. You can just get this converter from the converters class and then convert things. For example, if you want to convert a string into an integer or a string into a UUID or whatever, then you can just use that, and it has all these rules how to convert one object to another. I think it gets a little bit more interesting for this use case. You have an annotation, or you have let's say, a typed object. It could also be a plain Java bean with fields or with getter and setter methods in the end. And on the other end, you have a map with just properties. And now you want to convert that map into your bean or into this annotation. You just use a converter, and it does all the magic. It also handles, or it can handle default values and failures in conversion and all these things. So it's really very, very nice to use that one. Jumping to the next topic. So we did a lot of stuff, as you can see, in the R7 release. We updated the HTTP Whiteboard, which is used by Sling and AEM in the end. Added some improvements, clarified some things, and also added these component property types, which makes the development much easier. Again, it's on the next slide. And we also added a new specification about JAX RS. So if you want to use JAX RS with OSGi, there's now a specification for it. and an implementation, of course, you can use and combine these things. Just to show you again these new annotations, these component property types. We came up for various of these annotations for the HTTP whiteboard, like those over here. I guess this is only interesting for people who already used the HTTP whiteboard before. If you did so, you had to write these lengthy property statements there. They look really ugly. I mean, the last one still looks ugly, but at least the one before is much nicer now. And you see now here a usage of the service description property, and this and a service ranking also. And all these annotations will add properties to your component, and then when your component is registered as a service, these properties end up in the service registry. So it all gets way nicer than before. And final example, again, if you want to use structs.rs in OSGi, you can now just write plain declarative service components, and in that component you use the usual structs.rs annotations. That now fits nicely together. Okay. And final piece, we did some updates to the configuration admin to do some things nicer. But especially, we came up with a new specification, which is a configurator. And that one now defines a common format to specify a configuration in textual representation, which is based on JSON and looks basically like this. So for each configuration you use the PID, or the factory PID, as a key, and within that JSON object you specify the properties. And this format is now finally specified, and various tools can use the same format. Makes things much nicer. And we also use this format now in what we call the Sling feature model. And I guess we mentioned the feature model already several times in our talk today. There will be another talk about the feature model. So if you don't know what it is, you will see about it later on. And then there are other specifications which are very nice. I think a little bit more interesting maybe now is what is the future of OSGi? How does it look like? We don't know it, but we have some plans and ideas. The first one is very concrete. So there will be, I think even this year, the R7 enterprise release. And that one will contain the specification about CDI and how to combine CDI and OSGi, which is kind of nice. So you can use whatever model you want, and in the end combine them in a single application. For R8, the next version of OSGi, we have some ideas about the feature model, which is this app packaging, about how to make more sense about OSGi and JPMS, and some other things like real-time stuff. IoT, of course, is always a very hot topic in these things, and microprofiles, so this Java9 new thing, and how to make sense in combination with OSGi. And this is just to give you a very quick, rough overview of what we did, what we plan to do. If you have more questions, we have the roundtable tomorrow, I believe. Or pick us during the conference and ask questions, or use the final minute to ask the questions now. No questions. Thanks.
Thank you for your talk. The question is, imagine if we get a library, a third-party library with JAX-RS classes, and we do not have access to the source of the library. What do we have to do to use this library on OSGi platform? So the classes do not have annotations like add component, etc.
Mm-hmm.
Clear? Thank you.
Right. I think there is a way. I'm not quite sure about the details, but I think in the end you just specify the class names in your manifest, and then they are used. So you have to repackage that library, add a little information to the manifest, and then it should work, I think.
Any other? Yeah, there's another question here in the front. Philip, if you would just pass. Yeah.
You just introduced new annotations for like a service.
There was exactly.
This already.
Exactly. Sorry.
Okay. You introduced new annotations, for instance, a service ranking, which is really nice. But how about the annotation like a run mode, which will control which component will be active in case of Sling run mode? Have you considered that?
No, we haven't considered that because run mode is a very, very specific concept to Sling. So we don't want to add up these annotations in a more general, broader OSGi specification. That's one thing. The other thing is that run modes are really more intended as, or were initially intended as a provisioning vehicle. So using that in code is a little bit contradicting what we intended to do, what we intended run modes to be.
Yeah, I do have one question to Karl. So basically, you replaced the native JDK implementation with service mix and Geronimo bundles in Sling, right? And
Yes.
the question is, why did you pick those instead of the original ones from Oracle, which are supposed to be bundles as well?
Well, and partially that's why I wanted to mention it here, so that it gets a little bit of a broader exposure. So I mean, I'm not saying that the bundles I picked are the maybe not, are the optimal ones that I think are set in stone. It's more for now an exercise to show, okay, it's possible. That's one. I compared a couple of them. I'm still not sure whether the Geronimo spec ones are, or should be the ones, or maybe they should be replaced with the service mix ones. I'm not 100% sure. But in regard to the ones recommended in this JAP as replacements, or that are coming more from Sun or Oracle, the official ones, they for the most part have one or two downsides. One is they either GPL to begin with, or they are from Glassfish. And while we sort of technically could use the combination in the licensing with Apache, historically we had recently some contradicting things coming down from Apache that we shouldn't, do it for more safety reasons. So I think we could use the Glassfish stuff, but we try to avoid it for now. And that was why I didn't use those. I mean.
Okay, got it. Thanks.
But I'm certainly open for debating which replacements we should have. I mean, the benefit is up to a point that now it's in the provisioning. It really is just a question of, do I pick this one or do I pick that one? So you can change it, or you can change it yourself after the fact. So.
Any other questions? If not, thank you to Carsten and Karl for your presentation.